Okay, last time we talked about tangent mostly. So today it's going to be sine, cosine, and tangent, all three. So, like we talked about before, sine of the angle is opposite over hypotenuse. Cosine of the angle would be adjacent over hypotenuse, and tangent of the angle would be opposite over adjacent. So, if you look at A, okay, here's A, and they want sine of the angle. Okay, that's opposite over hypotenuse, so that's opposite over hypotenuse, so that'd be 3/5. Okay, cosine of A, adjacent over hypotenuse, so from A, adjacent would be the one close, but not the hypotenuse, right? So that's 4, and then the hypotenuse is 5, so it'd be 4/5. And then tangent's opposite over adjacent, so from here, opposite's way over here, adjacent's real close and not the hypotenuse, okay? So that would be 3/4. Okay, for sine B, that's from here. It's opposite over hypotenuse for sine, so you'd say 4/5. Okay, cosine of B, that would be adjacent over adjacent over hypotenuse, which is 3/5. And then tangent of B is opposite over adjacent, so that's 4/3. Okay, now looking at this, I guess we just wanted to show you that. Well, let me see. Where are we going to head toward? Let me see. Okay, so tangent of A is opposite over adjacent, so that's 8/15. This is just practice. Okay, sine of the angle is opposite over hypotenuse, so that's 8/17. And then cosine of the angle is adjacent over hypotenuse, so that's 15/17. Now, the idea is that you're eventually going to have just two numbers. Like if I had this covered up right here, then you'd be left with an opposite over adjacent, and that's tangent, okay? Or if this one was covered up, you'd say, I need to use opposite over hypotenuse. That's sine, so I'll use sine in this problem. Or if that one was covered up, that would be adjacent over hypotenuse, which is cosine. You won't have three numbers, you'll have two, okay? Or even x's in one number. So cosine of B, that's adjacent over hypotenuse, so that's 8/17. Oh, this is tangent, I'm sorry. Tangent would be, from B, would be opposite over adjacent, which is 15/8. Okay? Sine of B from here would be opposite over hypotenuse, which is 15/17. And then cosine of B is 8/17, because it's adjacent over hypotenuse, so it would be 8/17. All right. All right. So we're going to use sine to find the measure of angle A. Okay. Sine, remember when you find an angle, ding, 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 it's always the inverse function. Okay. So it would be inverse sine, first of all. And on Desmos, it just has inverse sine that you can punch in. On this one, you'll have to say second sine. Okay, right over the top of sine is the second sine. Okay, so you'll have the n -1, the inverse sine. Okay, and so once you do that, you have to put in the right fraction because it's opposite over hypotenuse for sine, so you would use 3/5. Okay, so you say 3 divided by 5, and you get about 37 degrees. Okay, so it'll round to 37 degrees. Okay, we can use cosine to find A. Okay, cosine is adjacent over hypotenuse, so the fraction would be 4/5. You know, and it's inverse cosine. We're finding an angle. Ding, ding, ding. Got to find an angle using inverse, right? Okay, so that's second cosine 4 divided by 5. Okay. Oh, guess what? It's exactly the same thing. It's 37 degrees, like it should be, right? Tangent. Guess what the answer is going to be here? Anyway, so inverse tangent. Okay, its fraction is opposite over adjacent, so that's 3/4. Can you see? Okay, 3/4. And then you punch in inverse tangent, or second tangent, and that's inverse tangent. And you put in 3 divided by 4, hit enter, and you get the same thing. So all of them are 37 degrees. Okay, so it just depends. Like I said, if I had this covered up, the only thing I could do is cosine, because that's adjacent over hypotenuse. This one covered up, that would be sine, because it's opposite over hypotenuse. And then if that one's covered up, then I'd have to use tangent. So you have to choose. Okay, so we're looking here. Which one do we use? Sine, cosine, or tangent based on the information? Okay, they give us perspective of the angle from right here, and that's opposite, right? And that's the hypotenuse, okay? Which one is that? Well, I can tell you, it's sine. Okay, so we use the formula, sine of the angle, which is 54 degrees, okay, is equal to opposite over hypotenuse. So x is opposite, and the hypotenuse is the 18. Okay, x on top, right? X on top, you multiply, remember? So these two multiply together, and 18 has to be in front of sine of 54. Okay, and really, you know, what we're finding is x, the length of this side. So we say 18 sine 54, bam. So it's 14.6. X is 14.6. Now, on this one, do we use sine, cosine, or tangent? Okay, this is an adjacent, and that's the hypotenuse, right? So I would use cosine. Okay, so cosine of 36, and then you've got 5 over t. This time the variable's on the bottom. Okay, whenever you have x on bottom or t on bottom, whatever, remember you have to switch and then divide. These switch places, right? So you'll end up with t on top, and then this will be on the bottom, cosine of 36, and then the 5 doesn't change, right? These just switch places. Okay, so you use your calculator and divide. So you say 5, don't forget divide. Whoops, something wrong. Okay, let's see, 5 divide by cosine, don't forget the cosine, 36, and hit enter. And so that's 6.2. So t is 6.2. Okay, the length of the hypotenuse. Okay, so another problem. This one, opposite over adjacent. That's a tangent problem, right? Opposite over adjacent. So tan of 28 is equal to opposite, which is 12, over x. So guess what? Switch and divide. Okay, so these switch, you're going to have 12 divided by tan 28, right? So that switches places, and the x goes over here, and it looks like that. So you would say 12 divided by tan of 28, and you would get 22.6. So x in this case is 22.6. All right, this one. Okay, angle's up here this time. This is adjacent, it's very close, and it's not the hypotenuse, okay? So adjacent and hypotenuse, right? I'll just put an A and an H, okay? So that's adjacent over hypotenuse. Remember SOHCAHTOA? CAH, cosine adjacent hypotenuse? Anyway. Okay, so this would be cosine of the angle, which is 53 degrees, okay? It's equal to m over 32. Okay, because adjacent's on top and hypotenuse is on bottom, so 5 over 32. Now, if the variable's on top, you just multiply these together, make sure the 32's out front. Cosine of 53. Just punch it in, that's what help you get m. So 32 cosine of 53. And that's 19.3 if you round it. So 19.3 is m. Okay, I already remember what's on the next page. Probably some ding, 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 some angles maybe. Oh, still a little bit more. Okay. Number 7 here. Here's the angle. This is the adjacent position. This is the hypotenuse position. So once again, it's cosine, isn't it? Okay, so cosine of 15 degrees is equal to 30, because adjacent's on top, over x. So it's a switch and divide. So you can put 30 doesn't change, right? This one exchanges with this one, so you'd have cosine of 15 here. You can write the x if you want to, but this is the key calculation. So you would do 30 divided by cosine 15. Oops, I'm in graphing. How did I get there? If you graph nothing and clear. So 30 divided by cosine 15, okay? And hit enter, and you get 31.1, which is how long x is. That's hypotenuse, okay? Now, I see that I'm solving for an angle. Ding, 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 ding. It's going to be the inverse key, right? Just which one is it? Okay. What position is this in? That's adjacent. Okay. This position is the hypotenuse. So adjacent hypotenuse, it's cosine. Okay, so inverse cosine, and which one goes on top? The adjacent does, because in cosine, it's adjacent over hypotenuse, right? So the 3 would go on top over 10. And we're finding an angle, so we use inverse cosine this time. Okay, that's second cosine on my calculator. On Desmos, just make sure it's in degree mode, and then you'll just find it under the functions. Use the scientific calculator, not the graphing calculator. Scientific calculator is better for trig. Anyway, so 3 divided by 10, and you get 72 something. So that's 73 degrees, okay? When it's degrees, I want it to be a whole number. When it's sides, I want it to be to the nearest tenth. So I want a little bit of separation between the two ideas. Okay, so ding, 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 finding an angle. You put the -1, right? You're going to have a fraction, but what goes in front? Well, depends on the positions. That's opposite, okay? And this is the hypotenuse. So opposite over hypotenuse, sine is equal to opposite over hypotenuse, okay? SOHCAHTOA. Anyway, so we would put 6 over 8, and then we use inverse sine, okay? So we say second sine 6 divided by 8, bam. Okay, so that's 49 degrees. Okay, so you've got a house, okay, somewhere like this. You got a house, and you've got this ladder that's leaning up against it, okay. It's got that's the ugliest ladder I've ever seen in my life. Anyway, so the ladder is 14 feet long. The angle the ground makes with the ladder, ground ladder, is this angle, and they tell us it's 57 degrees. Okay, what is the distance from the bottom of the ladder to the base of the house? So that's my x. Sine, cosine, or tangent. Adjacent, good grief, tangent. We've got cosine every time. I need to change this up. Okay, so that's adjacent over hypotenuse. Okay, so it's cosine. So we say cosine of 57 is equal to x over 14. Okay, x on top, you multiply and make sure 14 gets in front, right? So 14 cosine, can y'all see what I'm doing? Oh God, you didn't miss too much. Cosine of 57, I'm not gonna start over, almost done. Anyway, so cosine of 57, because it was x over 14, right? So if it's x on top, you multiply these together, the 14 goes in front, and you just punch it in. Okay, so you say 14 cosine of 57, hit enter, and it's 7.6. So my x is equal to 7.6. And we're done.